Look at us doing some two-step equations today, huh? Well. Here we go. Welcome to math class. An equation is a mathematical statement where two expressions are equal. Expressions are equal. Okay. All right. So a solution of an equation is a value that makes the equation true. That's cute. That's fun. Now, we often say things like isolate the variable. That means get it by itself. So isolate is to get, oh, it says it right there. Cute. In math, this means to get the variable by itself. So we're getting it down to just one variable on one side of the equal sign. Now the way we do that are with inverse operations. So operations that are opposites of each other. You know this, come on. So that would include, like, what's the opposite of addition? That's subtraction. So add and subtract. Divide and, the opposite of division, multiplication. Divide and multiply. Cool, man. All right, so we're going to get into it. We're going to get ripping, roaring, all that. Our objective, I will be able to solve equations in one variable that contain more than one operation. So our goal is to isolate the variables. Blank and blank by using the inverse. So we're going to say add and subtract. That's pretty easy, right? Those are opposites. And then the next one's going to be to multiply and divide. Those are inverses of each other. Multiply and divide. Yay! We did it, and we're having fun. Time to solve two-step equations. All right, so most of the time, you're going to isolate that variable by getting rid of addition and subtraction first, and then undoing multiplication and division second. That's not always the case, but a lot of the times that is the case. Now, if you look at example 1, we have 4x plus 3 equals 11. Now, some people find it helpful to put like a line down the equal sign, and they say if I do something to the left side of the equation, I have to keep it balanced by doing the same thing on the right side of the equation. Like if I was standing like this and I was on a balance beam, you put a 10-pound weight in this hand, I'm going to tip. But if you put a 10-pound weight here and a 10-pound weight here, I should, in theory, stay balanced. I'd probably be like this. But, you know. So 4x means 4 times x. So we're actually going to undo that later. This plus 3, it's all alone by itself. We could easily get rid of that. It's not attached to the variable. So we're going to do the opposite. The opposite of plus 3 is minus 3. But if you do it to one side of the equation, you have to do it to the other side to keep it balanced. Minus 3, minus 3. Because 3 minus 3 is 0, so it goes away. So all we have left on the left side is the 4x equals, on the right side, 11 minus 3 is 8. Now 4x means 4 times x. It's multiplication, so we do the opposite. So we're going to divide both sides by 4 here, because 4x divided by 4 is just 1x, which is what we're always trying to get it down to. And then 8 divided by 4 is 2. X equals 2. Now you can give yourself a quick check in the original equation and make sure that works. So 4x means 4 times x plus 3 equals 11. 4 times 2 is 8 plus 3, that is indeed 11. Okay. Example 2. This is a toughie because a lot of people will see the minus in there and they're like, opposite of minus is plus. But if I add 18 to both sides, 18 plus 18 would be 36. We're trying to get rid of the 18 here. It's out in front. It's positive 18. What is the opposite of positive 18? Negative 18. So we're going to actually subtract 18 on both sides here. Again, if you want to put the line down the equal sign, that's cool. You don't need to, but that is an option. 18 minus 18 is 0. So we have negative x over 4 equals 22 minus 18 is 4. Now, I see that's division, right? The x over 4. So I'm going to multiply. So I'm going to multiply both sides by 4. Also, I have to get rid of that negative. Nice thing is, if we multiply by negative 4, a negative times a negative cancels out and becomes positive. So we're going to multiply both sides by negative 4 instead. So the negatives will cancel. The 4 will get canceled by the divided by 4. So all we have left is x. On the right side, 4 times negative 4 is negative 16. If you'd like to check it, let's see, let's 18 minus x, negative 16 over 4 equals 22. So negative 16 divided by 4 is negative 4. We have 18 minus negative 4. And if you ever have minus negative, it's really plus positive. It's the same thing. So that would be 22 equals 22. Woohoo! We're having fun solving equations. Here we go. Example 3, example 4. Example 3, 1/2 x minus 9 equals 11. I see minus 9. What's the opposite? Plus 9. So we're going to add 9 to both sides of the equal sign here. Negative 9 plus 9 is 0, so those go away. So we just have 1/2 x equals 11 plus 9 is 20. When you have a fraction, so that's like 1/2 times x, right? So you're thinking, well, the opposite would be dividing. If we divide by fractions, though, you might remember this from way back in the day. When you divide by a fraction, it's the same as multiplying by the reciprocal. So you flip the fraction, it would be 2 over 1. So we're just going to multiply both sides by 2, and that'll cancel out the 1/2. Because half of 2 is 1, and we want it to be 1x, right? So these cancel, so just x equals 20 times 2 is 40. You could check that in the original equation. 1/2 x minus 9 equals 11. Half of 40 is 20, minus 9 is 11. That is true. Now, if you look at example 4, earlier I said most of the time you're going to get rid of addition and subtraction first. This would be one example where you're not going to do that, because this whole quantity, this whole x minus 2 or x plus 2 is being divided by 9. So we're actually going to cancel out the divided by 9 first, because we can't just subtract 2, because that 2 is still being divided by 9. So we're going to cancel out the 9 by multiplying a 9 on both sides. That'll cancel out the 9 in the denominator, so all we have left in the numerator is the x plus 2. On the right side, 5 times 9 is 45. Great. Now I see x plus 2. We have to cancel out the plus 2 by subtracting 2. X equals 45 minus 2, 43. Oh yeah, and we're having fun. Now if we substitute 43 in the original, that would be 43 plus 2 divided by 9 equals 5. 43 plus 2 is 45, and 45 divided by 9 is in fact 5. I believe I have 2 here for you to try out. There it is. So go ahead and pause the video here, try them out, and then check back in when you're done, because I'm going to go through these quick. And let's see if we got the same stuff. Let's see. So here we're going to add 2. 10x equals 40. 10 times x, so we're going to divide by 10. X equals 4. You could substitute that in. Negative 2 plus 10 times 4 is 40. And negative 2 plus 40 is 38, so that's good. Over here, we're going to multiply by negative 4 on both sides. A minus 10 is all that's left. 2 times negative 4 is negative 8. And then we'll get rid of minus 10 by adding 10 to both sides. Negative 8 plus 10 is 2. If you substitute that back in, 2 minus 10 over negative 4 equals 2. 2 minus 10 is negative 8. Negative 8 divided by negative 4 is positive 2. Unbelievable. All right, now we got some word problems. Fun. One cell phone plan costs $39.95 per month. The first 5 minutes of usage are free. Wow, that's nice. Each minute thereafter costs 35 cents. Write a rule that describes the total monthly cost as a function of the number of minutes of usage over 500 minutes. Then find the number of minutes of usage over 500 minutes for a bill of $69.70. So if we were to just create an equation here, our total monthly is going to, we have to pay the 35 or $39.95 regardless. Plus, we also have to pay for the additional minutes, anything over 500 minutes. Now, each one of them is 35 cents. When you see words like each or per, that usually indicates multiplication. So we're going to do 35 cents times the number of minutes over 500, right? Our first 500 are covered. So here's kind of a general equation, or if we wanted to turn this into, well, the next part kind of has us actually solve it. So it says, then find the number of minutes of usage over 500 for a bill that was $69.70. So our total is going to be 69, I'm not even going to write the dollar sign anymore, $69.70 equals $39.95 plus 35 cents per additional minute. Now look at that $39.95. That's just hanging out there at the end. So we can go ahead and just subtract that from both sides to cancel that out. Oh man, I'm going to have to divide by 0.35. Let me grab my calculator. 69.70 minus 39.95. We got $29.75 equals, these cancel out, 0.35 M. Now it's 35 cents per minute. So we're going to have to divide by the 0.35 to cancel out the multiplication. Divided by 0.35, whoops, 29.75 divided by 0.35. We got 85 for M. Now, if this was a word problem on a test, if someone said, hey, find the number of minutes of usage over 500, and you were like, M equals 85, you sound silly. Answer word problems with words. 85 additional minutes, or you could say 85 minutes. Now, if we were to take this next level and say how many total minutes were used then, we had 85 additional minutes. That was over the initial 500. So that would be 585 minutes in total. Wild, right? All right, so this one I do want you guys to try. A library receives a large cash donation and uses the funds to double the number of books it owns. I bet that word double is pretty important. If you're doubling $10, your brain is just like $20, right? You're multiplying by 2. Okay. Then a book collector gives the library 4,028 books. After this, the library has 51,514 books. How many books did the library have before the cash donation and the gift of books? So other important numbers, someone gave us 4,000 books, and In total, we had 51,514 books. I just want to make sure, okay, I do have enough time. So if we were to set up an equation here, let's say B is the books that the library had to start out with. It said that we're using the funds to double that. So we're going to multiply the number of books by 2. So we have 2B, or not 2B. Oh, good job. All right, then a book collector gives us 4,028 books. So what are we going to do with that? Here's our doubled books. We're also getting more books, so we're going to add it to that total. So plus 4,028, and this equals our total amount of books, 51,514. There's our equation. Now we're going to do our 2 steps. I see plus 4,028, so I'm going to subtract 4,028. To be, I know you're thinking it at home, folks. 51,514 minus 4,028. We got 47,486. We got to get rid of that 2. 2 times B, so we're going to divide by B, or by 2. 47,486 divided by 2 is 23,743. And what are we talking about? We're talking about books, baby. Whew, that was a tough one. That was tough. We have one more thing I believe we have to cover, and it is isolating a variable. So a lot of times later in this year, you're going to have equations and you have to solve for a variable. It means just get that variable to be the only thing on that side of the equal sign. So if you look here, P equals 4S, and there's 2 variables. It wants us to solve for S. So it wants us to get S to be the only thing over here, aka get rid of the 4. It's being multiplied. So how are we going to cancel out multiplication? By dividing. So all we have to do is divide both sides by 4, because 4 divided by 4 is 1. So we have 1s equals P over 4. There's nothing else to do. We got S all by itself, so this would be our final answer. I have one more for you to try. Pretty tricky though. So feel free to pause the video here, try it out, check back in, and then we're done. We're solving for y. So solve it like it said 4y minus 8 just equals 12, right? That you could do. You would get rid of the 8 first. So we're going to add 8 to both sides. Only problem is you can't do 12x plus just a standard 8. That's like 12 monkeys plus 8 telephones. You just leave them separate. So I'm going to put the plus 8 back here. We have 4y equals 12x plus 8. Now that's 4 times y, so we're going to have to divide by 4. If you do something to one side, you have to do it to the other side too. So we're going to divide every single thing by 4. Divide by 4, divide by 4, divide by 4. Y equals 12x divided by 4 is 3x. 8 divided by 4 is 2. And we are done with the notes. Look at us, we're so smart.